broadcast is now starting. All attendees are in listen-only mode.
Good morning, ladies and gentlemen, and welcome to the 2020's first Tech Talk. My name is Sean Frey, guys, and I will be your organizer for this morning. Now, just before I do hand over to Mr. Patrick Gordon, guys, there's a few little things I do want to go over with you, just to ensure that you do get the absolute utmost out of the session. Guys, at any point whatsoever, please feel free to drop a question into the questions tab. They come through to me and then I'll get them ready for Patrick at the end. Speaking about the end, guys, this is a 20-minute session and then we will allow 10 minutes of questions. So I will end the session off at latest 07:30. For those of you that are PIRB members, guys, this is CPD accredited, right? At the end of the session, there will be a survey which asks you to enter your registration number. Please take the 30 seconds just to go ahead and do that. It will make the PRB's lives a lot easier. Other than that, guys, these sessions are recorded. You can go ahead and find them up on the IOPSA YouTube page or on the app Plumber to reference at any time. And other than that, these sessions are sponsored by Heattech, so thank you very much. And then, guys, we are starting up with the rest of our courses up on the Articulate website. So if you do want to go in depth into any other topics, just go ahead and have a look there, and I'm sure we've got something for you.
Unmuted.
Guys, I'm not going to take up too much of your time. I'll hand it straight over to Patrick to continue this morning's session. Patrick, are you there?
Yeah, thank you, Sean. Okay, ladies and gents, welcome. As Sean said, we're talking about vacuum breakers and non-return valves. And I must say, when I was busy compiling this presentation, before the time I thought I knew what vacuum breakers and so forth were about and where to use them. But going through SANS 0252, it was quite interesting to find out that we don't know everywhere it has to be. So I'm hoping to bring all this information out to you guys. And let me just see why. There we go. Okay, so you'll see most of my presentation is taken directly extracts from SANS 10252 part 1, and we'll just work through it and we take it from there. So the first one is part 5.4, non-terminal fittings and components, referencing specifically to backflow preventers and vacuum breakers. Now, it's interesting, it says the capacity and performance of any vacuum breaker shall be such that no water previously discharged from any associated drawer fitting can return through such vacuum breaker. So we must install these vacuum breakers in such a way that any water that is being discharged, whether it be from the vacuum breaker, from the terminal fitting that it's attached to, or whatever, cannot be sucked back through that vacuum breaker. So in plain English, that vacuum breaker must be able to suck in plain air. No water must be able to be sucked in with it. Then it says, note there are two basic types of inline vacuum breakers, the atmospheric type. And if you have a look at the picture that I've attached, that's like on a flush valve or something like that. You've often seen the little hole on the side of it, which is open to atmosphere, and it can suck air through in there. So it's just open to atmosphere the whole time, but that line will not be pressurized. It says there the pressure type has a spring-loaded air inlet valve and check element biased to the closed position. So yes, a normal vacuum breaker that we get, we know that is normally closed, and it has got a spring-loaded little diaphragm in there, which keeps it closed, and it only opens up when we drop below atmospheric pressure. So those are the two main types of backflow vacuum breakers that we use in this country. And it says both types are only effective against back siphonage. So we can't use it for something else. It's only to prevent water from being siphoned out somewhere or cross fixture siphonage, anything like that. It's just for that only. So then we go to 7.4.3, which is on backflow prevention, And it says adequate measures shall be taken to prevent the back siphonage of water into the following. Then it goes a communication pipe from any of the following water installations. The first one is fire. We're not going in there. We're talking about domestics today. So that takes us to part 2. It says a general installation serving any of the following activities. So yes, it'll be veterinary installations, medical, doctors' rooms, agricultural, dairies, things like that. But one that we often skip is this one, laundering and dry cleaning. Now, I think every single one of us has a washing machine at home. And did we know that there should be backflow prevention on that? Now, in a discussion earlier this week we had about the webinars and so forth, Herman Weber came up with some interesting information, and I'm just dropping it onto you quickly. It's a South African Domestic and Appliance Association. They have a regulation which shows that washing machines, dishwashers, and washer dryers have to have a system that prevents water once discharged in them from returning to the main water reticulation system. And that's according to the international IEC legislation and not only the European. The European appliance companies are certified by a CAB, which is Customer Advisory Board, using that EN standard. So most of the washing machines and so forth that we do get here in South Africa have got this backflow prevention already built in. But according to SANS 10252, that isn't sufficient. We don't know what laundry equipment is going to be attached to that washing machine point. So we still have to have sufficient backflow prevention, whether it be a vacuum breaker on that line or a check valve, to make sure that there is no backflow from our laundry at home. Then it carries on under 743, and it goes down to point 3. 9, and it's just coming up on your screens there now. It says any other premises on which an activity is carried out that can affect the potability of water. Now, we've got many installations at our homes which can affect the potability of the water, whether we are watering the garden, things like that. And there's specific regulations that covers that also, and we'll get to those just now. But then if we have a look at B1, it says something very interesting. It says the design of terminal fit, or an installation in all cases where the design of the terminal fitting installed, including any hose bibcock, laboratory tap, or movable shower unit is such that a hose or any other flexible pipe can be attached to the fitting. And I think most of us have got a hose tap somewhere on our property. And then there has to be backflow prevention there. Now, some of the municipalities, and I always thought Cape Town was way out putting that in their municipal bylaws, that all outside garden taps have to have a vacuum breaker attached to it. And I thought they were like really going over the board. But if we look, it's in our national regulation here. If there is a hose bibcock, there has to be backflow prevention in the form most probably of a vacuum breaker on that line. Then it also carries on, and it shows here an underground irrigation system can provide contact between polluted water and within the installation. So most of us have got a hose bib tap or a irrigation system. Now, not all of us have these fancy pop-up systems. It could just be one that plugs into the ground, but if it is one of these pop-ups where it drops below the ground, that unit there can be filled full of water that could be contaminated with pesticides, with all sorts of agricultural products and so forth, and it can be sucked back into the main system. So any of those type of installations on our property, we've got to have these backflow units installed. So Are we getting scared yet? I got scared when I went through this. If we then move to 7433, and it says that unless other approved measures are taken to prevent the backflow of water from terminal water fittings that discharge water into a sink, wash basin, bath, or other similar appliances, a double check valve shall be incorporated as close as practical to the point of discharge. Okay, so that doesn't mean that for every tap there's got to be a backflow prevention or anything like that, because it refers us, if we look at point A, to this table. So most of your pillar taps, mixers and so forth discharge the water quite a bit higher than the floodplain of that basin. And it tells us, for instance, on a 15 millimeter tap, the vertical distance between the tap outlet and the spillover level must be 25 millimeters. For a bath, for instance, which has got a 20 millimeter tap, the greater of 70 millimeter or twice the nominal size. So it'll be about 70 millimeter. So that's fine. Most of our taps and mixers, the way we install it, would comply. But there are certain installations where we have to keep it in mind. We have these little nicky spouts, or the combination bath filler spout that is very popular these days, where there is no spout coming from the wall. Your overflow and your bath filler all sits in one. The problem with that is looking very nice, but it's below the floodplain of the bath, or the overflow rim of the bath. Now, the SABS ones that you do get do come with a check valve in there, but that is not sufficient, because if we have a look at point B here, it says that a double check valve shall be incorporated as close as it is practical to the point of discharge. So even though we've spent that extra money, we've done due diligence and fitted the SABS compliant one, we didn't take cognizance of this part of the law, that there's got to be a double check valve. So we would have to put another check valve as close as possible to the point of discharge. And if we have a look further in the law, it tells us that that point must actually be serviceable. We must be able to go in and have a look at it and see that it's still working, clean it out, that type of thing. So that is something that we've got to keep in mind. With most of the houses that we're doing installations at, we are using these units these days. So if we then carry on to the next point, which is 74314, and it refers us back to specifications given in 6331. And I'll just pop 6331, and I see the internet seems to be a little bit slow, but it's popping up there on your screens now. Give it a couple of seconds. Yes, there it is up now. So if we have a look at 6331, it tells us that a vacuum breaker shall be positioned at a height of at least 150 millimeters above the overflow level of any receiving appliance, such as a cistern or vessel, when the latter is fixed, or 300 millimeters above the outlet of the fitting in any other cases. So it's telling us that where we have a filler tank or something like that, a header tank, there must be a vacuum breaker positioned at least 150 millimeters above the overflow level. So even on your cistern in the house, most of those filler valves have got a little back siphon protection hole in there. But the problem is most of them are lower or in line with the overflow level of this appliance. So it would not be sufficient. You would have to put another vacuum breaker on the line at least 150 millimeters above the overflow level. So that's something I've never seen anybody do. And yet it's there in SANS 10252. So we see then in 743.4, it says, unless we have done this, okay, it says that we can provide a vacuum breaker shall be installed at the highest point of an upstand at least 300 millimeters above the point of discharge of the highest terminal water fitting concerned. So what it's saying here is, if we've got a whole line of cisterns maybe on one line, at the highest point, 300 millimeters above that floodplain, there must be a vacuum breaker. So unless you've complied with 6331, which is a vacuum breaker at each toilet, there you would now be able to put it on one vacuum breaker at the highest point, 300 millimeters above. So a terminal vacuum breaker shall be so installed that it is situated at least 300 millimeters above the highest point of connection of any pipe to a riser serving terminal water fitting concerned, or a single check valve or vacuum breaker shall be installed next to any terminal water fitting unless such a terminal fitting incorporates a single check valve or vacuum breaker. So if we are fitting terminal fittings which already incorporate a vacuum breaker that is higher than the overflow level, or it's got a non-return valve in, then we don't need to put that vacuum breaker on there. Then the last one we have a look at is 84.2, and it says any backflow prevention device shall be installed in such a position that it can be readily inspected. So these vacuum breakers and non-return valves are all referred to as backflow prevention devices. So they must all be installed in such a way that they can be easily inspected, that the condition of backflow in the pipe in which the device is installed can be readily detected. It is readily accessible for removal for the purpose of servicing, repair or replacement without altering the water installation or to the structure within which the device is situated. An important one is it cannot be flooded by water or any other liquid. So it's got to be installed in such a way that it cannot suck back any water into the system. And in the case of a vacuum breaker, it is installed on an appropriate anti-siphon loop. Now that part there, we often forget about also, especially when it comes to geyser installations that have got solar panels and so forth attached to it. Quite often people are putting an anti-siphon loop by the geyser, but yet that is not the highest point of that installation. You actually need to take that vacuum breaker and anti-siphon loop higher than the solar panel. Otherwise, it's not an anti-siphon loop. So these are all questions that we've got to put to ourselves. How accurately are we sticking to the basic installation requirements of backflow preventions and vacuum breakers? I know it was a bit of an eye-opener for me, and I'm sure to many of you guys, you may never have seen these points before either. Some of you may be complying to it, I'm not sure. But I haven't seen many installations which comply to all these things. So I think we've all got a little bit of work to go and do to the installation and designs that we are doing. Okay guys, that brings me to the end of my little information that I've got there. I know we've gone through it very fast and so forth. If you guys have any questions after this, I know we're opening up now for a question and answer section, but if later you do have any more questions, you're welcome to get hold of me. You've got my contact details on your screen, and then we can take it from there. But for now, let's ask Sean to tell us what questions have come through on the chat line.
All right, perfect. Thanks so much, Patrick. The first question here reads, so you must install a vacuum breaker on each point 150 above the offer flow level.
Yes, that is according to 6331, and it says later on 7.4 that if you haven't done that, then you can actually, if there's like a whole bank of toilets, for instance, that you've got together, you can put it 300 millimeters above the highest one. So yes, there are, if you've got separate installations, it must be 150 millimeters above, or if you've got a bank, then it can be 300 above the highest one.
All right, 100%. Then the next one here reads, did I understand this correctly? We need a vacuum breaker on every WC cistern, garden tap, bath tap, mixer with Nicky spout.
Yeah, not every tap, because if your tap is, the outlet of the tap is more than that, well, on a 3/4 tap 70, on the others it's 25, above the floodplain or the overflow rim of the basin, there you don't need a non-return or vacuum breaker because you've got an air gap, and that is a backflow prevention already. But any place where you've got a Nicky spout or the discharge is lower than the overflow rim, you should have a vacuum breaker on there.
All right. The next question I've got here reads, must a NRV be installed after the water meter then?
There's nothing that says that an NRV must be there. A non-return valve, I take it you're talking about. For another topic that is coming up in the Tech Talks, and you guys can look out for that, is on RPZ valves. Almost every property should have a RPZ or a reduced pressure zone backflow preventer on, and that is another thing that we need to look at. But as I said, that is for another Tech Talk that we will discuss that more in detail.
All right, perfect. The next question here reads, clients and architects do not want inspection holes, especially in curved bathtubs. How do you make the NRV serviceable?
We would have to put that in a service duct or the outside wall. I know it becomes very complicated and difficult. Your interior designers and so forth are very critical about hiding these things so you don't see them and that type of thing. Yes, it is a challenge. But normally we can put one somewhere on that line. As the Sans said there, it must be as close as possible. Now, if the customer is full of nonsense and we can't put it fairly close, let's at least put it on the line that supplies that, at the highest point of that line that supplies it, so that we are going to be drawing in air instead of back siphoning.
All right, perfect. The next question reads, how would we install a vacuum breaker if all the pipe work is done in the wall?
As I've just said, sometimes this becomes a little bit critical, but yes, you would have to. Unfortunately, that is something, and that was a discussion I had the other day. Unfortunately, we as the professionals have to guide these designers and architects and so forth when it comes to their designs. It's not just our problem. They are the ones that must now give us the reticulation designs and so forth for these installations. But let us remind them of what the law says, and they've got to keep it in mind when they are doing their designs, so that they can facilitate places like an inspection panel on the outside or wherever. They have to include it, unfortunately, for them.
All right, perfect. The next question here reads, can we install a 1 RPZ instead of these individual vacuum breakers?
The law doesn't say that. It doesn't say either or. It's asking for both. So I would say no. We need to put the vacuum breakers, because remember in that last section 7, it says that it must be able to indicate that there is reverse flow taking place. Now with vacuum breakers and so forth, it's going to prevent that backflow, but we will not be able to see if there is anything going wrong. So your RPZ, to me, is almost like the safety valve on a geyser installation. You've got your pressure reducing valve, you've got your expansion relief valve, you've got the thermostat which is doing all the work, but right at the end, if everything fails, your safety valve is going to give you an indication of a problem. And the same with this. Your NRVs and vacuum breakers and so forth are there to do their work. The RPZ is there as a final backstop to make sure if anything goes wrong that it doesn't.
All right, the next question here reads, NRVs are widely used as RPZs. So is that wrong in a normal house?
Correct. As I said, it shows that it must be able to give you an indication of backflow taking place. A normal non-return valve, single or double, doesn't give you that facility of indicating the presence of backflow taking place. So if for some reason your non-return valve is stuck in the open position and backflow is taking place, it must be able to indicate to you that backflow is happening. And those normal NRVs cannot do that. Only your RPZ can do that.
All right, perfect. The next question here reads, if your system, I do apologize, reads, if your system is balanced and you have 2 vacuum breakers at geyser, must you still install a vacuum breaker at each system?
That's what the law says, yes.
All right. Then we've got a question here which reads, can we access the diagrams of these specific installations online?
I'm not sure if they are in SANS 1025 2.1. I didn't go that far to check it, but I'm sure if it is available somewhere, it'll be on 025 2.1. If whoever posted the question, if they want to get hold of me afterwards, I'll do a bit of research and see if we can get actual drawings on that.
All right, perfect. The next question I've got here reads, or it's more of a statement, reads, we can't because we do not have access to and our governing bodies have no say in their governing bodies. Plumber has no say in the architecture.
Well, unfortunately, they cannot overrule the national regulations. So we do actually have a say. They can't get occupation without a certificate of compliance. So you cannot issue a certificate of compliance if it doesn't comply. So yes, we may feel at present that we are being forced to break the law, and these guys are trying to push down their laws on us, but unfortunately we have the upper hand because we have to abide by the national regulations, and it's not negotiable.
All right, perfect. The next question I've got here reads, can we fit the vacuum breakers on the droppers in the roof if we cannot access the hatch above the bath?
Yes, I would definitely say so, because that is your high point, and that does fit in with the description of SANS 10252, where it says that if you cannot put it there, you can put it at the highest point, 300 millimeters above the highest point. So yes, you definitely would be able to.
Right, perfect. And then I think the last question we've got time for reads, so every house should have an RPZ. It will cost a fortune on RDP housing as the valve is half of the cost of the house.
Yeah, I hear what the person is saying, but if your RDP house doesn't change the color, taste, and temperature of the water, you don't need a RPZ valve. And yeah, as I said, we get to this in another tech talk really, but as soon as there is a geyser on the installation, you have to put a RPZ valve. If there is a garden tap which they will be irrigating from, you need to put a RPZ valve.
Right, 100%. Thanks so much, Patrick. Would you like to say something to end off?
Guys, just thank you once again. I know it is half an hour out of your busy schedules, but I think these tech talks are great. It helps us get information that we previously may not have taken cognizance of, and I appreciate the fact that we could share this time with you. If you guys once again need further information, you've got my details on your screen. If you have missed it, please get hold of Articulated. They will be able to give you my details.
All right, perfect. Thanks so much, Patrick. Guys, I do see that we have still got quite a few questions here, which I will send through to Patrick during the day. Other than that, guys, I have got a couple of questions just again asking where the videos are posted. These videos are posted up on the IOPSA YouTube channel as well as the App Plumber, so you can go ahead and look for them there. This video should be up before the end of the day, so you can go ahead and look there for it. Other than that, guys, thanks so much for joining us. Please do remember the survey on the way out. And then just before I do forget again, guys, the Tuesday morning Toolbox Talks presented on OHS in the industries. That Toolbox Talk session is now also accredited with the PIRB. So if you would like to join that session, it is also CPD accredited. You can go ahead, just email us, and then we do send out the links, and we will send you guys out a link to register for that during the either today or tomorrow. But you can go ahead and look out for that and register for it if you would like. It is another free session. All right, 100%. Thanks so much, ladies and gentlemen, and enjoy the rest of your day. Bye, guys.